Hi everyone, welcome to Percona Live 2021. I hope you're enjoying this live event and thank you Percona for hosting this event. Many applications, including modern day serverless architectures, allows applications to scale seamlessly. And it opens and closes large number of connections to the backend database, exhausting its resources. And the applications has a requirement of high availability to handle the transient database failures, and more importantly, it needs a better security. In this session, we're going to talk about how Amazon Proxy helps scale your applications better without affecting your database performance. My name is Surendar Munimohan. I'm a database specialist solutions architect here at AWS, focusing on MySQL engines. I've been with AWS for over 7 years on various other roles before joining the solutions architect team. Here's an agenda for today's session. I'll first introduce you about what is Rds Proxy and why we built it in the first place. Next, we'll briefly discuss about how Amazon Rds Proxy works. Then, we'll discuss about the three key benefits of Amazon Rds Proxy on how it helps your application to scale better and make it highly available and better security. And I'll show you a demo on how Rds Proxy handles the application's connections and how it increases your application's availability through the database failures. We'll finish up with some of the best practices when using Rds Proxy. We have a lot to cover in this session. Without further ado, let's get started. Modern day applications move towards the microservices and serverless architectures. This allows applications to scale without any issues. For example, AWS Lambda functions can scale up to 100,000 invocations very easily. But think about all these Lambda functions opening hundreds of connections to the backend database. Then your DB instance will be using most of its resources in managing these connections instead of processing the queries. And this will decrease the database performance. And all the applications want to have high availability and ability to handle the transient failures. These transient failures are common in the cloud environment, and these failures are greatly minimized in RDS and Aurora. It automatically detects these transient failures and perform the failover without any manual interventions. Even though this failover time is very fast in Aurora, most of the applications has a requirement to handle these failures with a less or no interruptions. And applications has a requirement on having more security control so they can maintain a better security access to the database. And prior to launching Rds Proxy, what are the customer choices? To handle the high number of application connections, customers typically would over-provision the DB instance so it has enough compute and memory resources to handle these connections. In addition to that, you also need to maintain a complex failover handling mechanism in your application code to overcome these transient failures during the failover events. And the other option is to self-manage your database proxy solutions in an EC2. Running a self-managed proxy solutions comes at a cost of deploying it and maintaining it. It comes yet another component in your application architecture that you have to take care of. And also, it's an entry point to your database. So you need to make sure it's highly available and handle the failover logics. Based on the previous feedbacks from our customers, they wanted a fully managed proxy solution. That's the reason we built Rds Proxy as a service. Rds Proxy is a fully managed, highly available database proxy that makes your applications more scalable, more resilient to database failures, and more secure. Let's discuss about Rds Proxy features and benefits briefly here. As with most of the AWS services, Rds Proxy is a fully managed service, which means you don't need to deploy and maintain it. We take care of this maintenance like patching, upgrade, and setting up a high availability. It is fully compatible with the MySQL and Postgres, which means if your application using MySQL or Postgres database, you just need to change the database endpoint to Rds Proxy endpoint in your application code, and you're good to go. And what are the other benefits that you get from Rds Proxy? Rds Proxy performs connection pooling with multiplexing. It means whenever the connection is not actively executing, we switch it to another connections and do the work. So this helps to minimize the amount of connections that you open to the backend database, which in turn reduces CPU and memory consumption of your database and increases performance, right? The second key feature is a fast and seamless failover. As you know, in Aurora, the failover is very fast. It takes less than 30 seconds. During this process, all the application connections get dropped because DB instance will have to reboot. So application have to reestablish the connections back to the database again. But when connecting through the RDS proxy will preserve these connections as the failover happening, and it will direct the connections to the newly promoted instance when it becomes available. RDS proxy aware of these underlying instances, so it is very fast in detecting the role changes, and it is not relying on DNS. So you don't need to worry about DNS caching or downtime TTL delays. Because of that, it is able to provide 66% faster failover. And the third key feature is the security. RDS proxy integrates with the AWS Secrets Manager, so you don't need to store any credentials in the RDS proxy. On top of that, RDS proxy allows you to enforce the Iam authentication. This means it is supported for this Iem authentication is supported for both for RDS and Aurora. With this, you can enforce all users connecting to the RDS proxy must use Iem authentication and avoid hard coding database credentials in your application's code. We'll discuss a little more details about each features in the coming slides. Before that, I want to briefly discuss about how RDS proxy works. On the left-hand side of the screen, you can see you have your applications. It can be running in serverless or PHP or Ruby or .NET or in the containers, right? On any of these applications can connect to RDS proxy. On the right-hand side, you have your database such as RDS or Amazon Aurora. RDS proxy sits in between your application and database layer. So your applications connects to RDS proxy, and it provides all these features like connection pooling, seamless failovers, and better security controls like enforcing authentication via IAM, and also integrating with AWS Secrets Manager. And the RDS proxy will connect to your backend databases, such as RDS or Aurora running MySQL or Postgres. Let's dive a bit deeper into how RDS proxy helps your application scale better. RDS proxy performs connection pooling, which minimizes the number of connections that you open to your backend database. MySQL uses one thread per connection. When you open 100 connections directly to the MySQL, it creates 100 threads. When application opens and closes database connections at a very high rate, a lot of database resources will be spent on managing these connections instead of processing these queries, and which eventually degrade the database performance. RDS proxy also support connection pooling for both read-write endpoint as well as read-only endpoint for Aurora clusters. As you know, in Aurora, you can have up to 15 reader nodes. When you're connecting to the RDS proxy read-only endpoint, it automatically performs the load balancing between the reader nodes. And during the role change, RDS proxy checks the replication lag of the old and new reader instance and routes a connection so that your application never sees the stale data. RDS proxy performs connection multiplexing. It reuses the same database backend connection to serve multiple requests. For example, whenever the connection is not actively executing or waiting or just idle or waiting for a user input, during that times, connections switch to another connection to perform the operation. The connection multiplexing would work for both read-write endpoint and the read-only endpoints. With this, you can increase the scalability of your application without overloading the database, compute, and memory resources. Let's discuss about how RDS proxy improves your application availability. So this is a simple example to showcase how RDS proxy improves your application availability. Let's say you have an application connected to the backend database, either to a RDS or Aurora instance via RDS proxy. In this case, it has one primary instance, which is represented in red, and one standby instance, which is represented in blue. When there is a failover, RDS proxy will preserve the connection which are not active, and it will continue to accept the connection from the application even during the failover process. And it will continue to queue up those connections in RDS proxy. As soon as the new instance comes up, it'll connect to the promoted instance and pause any pending transactions that are queued up in Rds Proxy. Now, if you're connecting directly to the Aurora cluster endpoint, overall the failover takes less than 30 seconds. In that 30 seconds, most of the time goes into DNS propagation. On top of that, if you have a downstream TTL, or if you have an application side connection pool with long living connections, your failover experience or the failover time becomes even longer. With RDS proxy, it directly connects to the Aurora instance and it is fully aware of your cluster topology. So whenever there is a change, it quickly detects these changes. Because of that, it provides up to 66% faster and seamless failover. I wanted to show you about the tests we performed. In this test, we used a client to directly connect to the database and to the proxy, and we did about like 100 iterations. We measured how long it will take for a client to reconnect and execute the transaction after the failover. The orange line shows the direct connection to the database and the failover time as a result of that. And we use MariaDB driver, which is already optimized to reduce the failover time. With that, we notice the time it takes for the client to reconnect and execute the transaction anywhere between like a 10 to 30 seconds after the failover. And the blue line shows the client connecting using RDS proxy. As you can see, the time it takes for the client to reconnect and execute the transaction after the failover, typically it takes around 3 seconds. As you can see, with RDS proxy is able to provide you a faster and even when you are compared with the optimized MariaDB driver. Let's dive a bit deeper into RDS proxy security aspects. First, I want to talk about how you can authenticate and authorize with RDS proxy. You can continue to connect with RDS proxy using the native way that you establish a connection with your MySQL and Postgres database using a username and a password. The next option is you can store the secrets in the AWS Secrets Manager. With the AWS Secrets Manager, you can easily rotate, manage, and retrieve the database credentials. You can just make an API call from your application to retrieve the secrets and start the connection. And another added layer of control is that you can use the Iam Authentication with RDS proxy. It is much more secure than connecting using the username and the password. Once you get authenticated with RDS proxy with any of the above methods that I mentioned, then RDS proxy will get the credentials from the secrets manager to connect to the database. I want to show you where you can enforce the IAM authentication on the RDS proxy console. You can see there's an IAM authentication in the connectivity section where you can set an IAM authentication to required. It is very straightforward. I want to briefly explain about how IAM authentication works. First, your application gets the authentication token from an IAM service. Using that authentication token, your application makes a connection to the RDS proxy. Once that is validated in RDS proxy, as mentioned previously, RDS proxy will retrieve the database secrets from the secrets manager and connect to the database. By using this technique, you can enforce a strong authentication requirement for database applications. Now you know how IAM authentication works and where to enable it in the RDS proxy console. Now let me show you how can you use it in your code. It is a sample code snippet in Python. It is very much the same for other languages as well. The first highlighted line shows how you generate an IAM token. The next line shows how you use the token as the password. This authentication token are generated using AWS Signature 4 version, and it has a lifetime of 15 minutes. This is a very simple and a very secure way to connect to a database without storing the passwords in your code. I want to discuss about the new feature that we recently introduced in RDS Proxy. Typically, customers run their app servers and the database servers in one VPC, but on different subnets. Given both app servers and database servers are running in one VPC, it is easy to provide access between each other by just allowing the security groups or giving access to the subnet range. Now let's say if you have some reporting applications running in a different VPC in the same AWS account, and that want to access the database which is running in another VPC. You can use a VPC peering between these VPCs, but in this case, you will be opening up the connectivity for the full VPC, even though you just want to access the database. With Rds Proxy, you can enable the cross VPC connectivity by just creating the endpoint in your Rds proxy. Using this endpoint, your application in another VPC can communicate to the Rds proxy in another VPC. With that, let's jump into the demo. To save us some time, I already created the Rds proxy. It is very easy to create with just a few clicks. So I created this proxy with just a writer endpoint. As you can see the endpoint in here, and you can see the database associated with this proxy. I wanted to show you the security groups because this is where you allow your application to connect to the proxy. So let's go back to the VPC management console. Here we can see the three security groups. So first one is an application security groups where I allowed port 22 for my IP address. Next, I want to show you about the Rds proxy security groups. So in this Rds proxy security group where I opened MySQL port 3306 for my client security group. So that is there. And next, I want to show you is the database security group. So in the database security groups where I allowed access to my DS proxy and also for the client which I'm going to connect, right? So I opened 3306 for both for my proxy and also for my client. So that's what it is. So now let's go back to the Rds proxy console. Let's check the database associated with this Rds proxy. So here you can see the database associated with it. So let's go and check the database now. So in the Rds console, so we have Aurora cluster. So Aurora cluster with the reader and the writer. So both are running on db.r5 large instance class, and this is a cluster endpoint. So I'm going to use this cluster endpoint to connect. Let me open up my terminal and connect to the Aurora cluster using MySQL CLI command. Now I'm connected to the Aurora cluster instance. So here I'm checking the current timestamp and the max connections and the current connections on this particular instance. There is not much going on this DB instance. I mean, yes, you can see there are 8 connections, right? There's not much going on. These 8 connections which are running for the RDS monitoring. I also configured the CloudWatch metrics I want to show you. So in this CloudWatch dashboard, what we are showing is there's a 2 metrics that I configured. One is for the DB connections, and next one is the proxy connections. So we're going to be monitoring these 2 connections and see how much RDS proxy is handling and how much that backend database is handling. We'll come back to that. So next, I want to show you the Lambda functions. This is a very simple function. I'm running it in a loop, which is connecting to the backend database and executing a simple query, as you can see. I'm going to use this Lambda function as a client. To simulate the additional load, what I'm using is an artillery. It's an open source load generation tool. Let's go ahead and start the load. So this will start firing the Lambda functions. So as seen before, each Lambda functions is going to create like a 10 connections each. So now we have started the artillery. Currently it's launched 66 Lambda functions, and each Lambda functions will create 10 connections and it will continuously going to increase. Let's go back to the CloudWatch and observe the load here. So the CloudWatch will report every minute. So we'll be getting our first data point soon. There it is. We got the first data points for both for RDS proxy connections and as well as for the DB connections. And it's going to continue to increase as artillery kicks in more load. Okay, currently there are 10,000 connections on the RDS proxy and just 900 connections on the database. And it's because I've configured the proxy to have only 90% of the connections. So 90% of 1000 is a 900 connections. So that's what we are seeing here. Now, this is going to reach its peak. Okay, there it is. So it reached like a 15,000 connections. RDS proxy is handling like a 15 times as much as the database could have supported on its own. That shows the immense power of RDS proxy. Now I'm going to move on to the next phase of the demo. Here I will show you how seamless and faster failover work. Here I have a same Aurora cluster with the two instances, one writer and one reader. I'm going to use the cluster endpoint to connect to the instance. Let me open the terminal and connect to the instance using the MySQL command line tool. Here, what I'm going to do is I'm just going to use the script and going to run against this cluster. Basically, what we're going to do is we're going to check the current timestamp, max connections, and the current connections. As you can see, the query is executed 4 times every second. While this is running, let's go back to the console and initiate the failover. Do it and select the failover. Okay, the failover process is kickstarted. Let's go back to the terminal and monitor the connections. So let's wait for the failover to take place. While the failover happens, you'll see the connection to the database will be interrupted. Okay, let's wait for the process to kickstart. Oh, there you go. So as you can see, the connections to the database got interrupted, client reporting it not able to connect to the server because of the reboot during the failover. So let's stop the script and we can see it took about almost 7 seconds to perform the failover and to start the new connections. This is already very fast because Aurora storage, underlying storage architecture. Now let's do the same for the proxy endpoint. Let's go to the proxy console, like this, and let me capture the proxy endpoint and run the same script with the Rds proxy endpoint. Let me do that and let me copy the proxy endpoint. Let's start the script. While the script is running, so basically it's doing the same thing. So while the script is running, let's go back to the Rds console and perform the failover again. Select the instance 1 and do the failover. So now let's go back to the terminal and monitor the behavior. We're still seeing the same connections. What we are looking for is a number of current connections to drop. Let's wait for a moment. Still going on. We don't see any drops yet. Oh, there it is. Let's stop the script. So as you can see, there's no interruptions here. We just see that there's a drop in the connections. Within 2 seconds, it was able to reconnect to the database. The current connection drop we see here is because of the database restart, and that concludes this demo. I wanted to share some of the best practices that we learned from our customers when using Rds Proxy. Applications don't continuously use the connections. If you open a connection, you perform a transaction and done with it. And this connection will be used for another transaction, so on and so forth. RDS perform the transaction level sharing and load balancing that improves the scalability of your application. RDS proxy detects when the transaction ends through the network protocol used by the database client applications. And it does not rely on the keywords like a commit or rollback. Because of that, your database CPU and memory resources are used to process these queries instead of managing these connections. And there are certain situations where multiplexing may not work. For example, when you change the session variable or changing some session configuration parameters. I will show you more on what are the situations your connection get pinned in the coming slide. And during these states, the connection get pinned to the same underlying database connections until it ends. And RDS proxy will stop sharing these connections. Think about if you're allowed to do that, then we'll be leaking the session state, and we don't want to do that. To safeguard that, RDS proxy does the connection pinning. Next, I want to show you is what are the situations the connections pinning can happen. When you're setting the sessions variable using the set command or doing an explicit locking like a lock table, or when creating a temporary tables, or when using the prepared statements. During these statements, your connection gets pinned. And when you run a large query that text size is greater than 16 KB, then your session gets pinned. These connection pinning won't affect the character set changes or collations or time zone or auto commit or SQL mode settings. So you don't need to worry about the connection pinning for these because RDS proxy will detect these changes. And calling stored procedures or stored functions does not cause pinning. RDS proxy does not detect any session state changes resulting from such calls. So make sure your application does not change the session state inside the stored routines and rely on the session state to proceed across the transactions. So even when the connection get pinned before, we'll reuse the connections after the client goes away. So another thing to note here is when the failover happens, the database gets rebooted. The appended connections will get dropped. And those connections cannot be seamlessly transferred to the new instance. So in those cases, your applications needs to reconnect and set the session state again. I wanted to quickly show you how can you avoid pinning in the Rds proxy console, right? If you don't care about the variables that being shared between the sessions, you can exclude the variables by using the first option, that is the session pinning filters. The other option is initialization query. If you set the statements to perform an identical initialization for each client session, you can do so while preserving the transaction level multiplexing. Here you can define the query for a proxy that sets the current configuration parameters. Then Rds Proxy apply those changes whenever it sets up the new connections. And Rds Proxy publish a lot of metrics for you to review and understand the proxy usage. I have highlighted the few metrics that you need to keep an eye on. Make sure you don't have too much pinning happening in your workload. If you do that, then you have high connection pinning that you're reducing the connection multiplexing. Check your application code and avoid unnecessary database requests that might cause pinning. Next is the database connections and the database connection currently borrowed. If these two metrics are almost same, which means your database is running at its capacity, you might want to look into how to scale the database to get more connections. To summarize the session, I introduced you about Rds Proxy and how Rds Proxy helps scale your application, increase the availability, and make it more secure. And we discussed about the benefits of using Rds Proxy. And in the demo, I showed you how Rds Proxy handles the influx of connections without affecting your backend database. And in the second demo, I showed you how Rds Proxy helps your application to be highly available even during the database failures. And we finish up with some of the best practices that we learned when using Rds Proxy. With that, we came to the end of the session. I hope this session was useful, and I would encourage you to try Rds Proxy if you haven't already. And thank you so much for watching this session, and enjoy your rest of the sessions.